What's up, everyone? All right. So, got some new lighting going on. That's some fun news today. Hopefully, this looks a little bit better. I was noticing my face was a little bit darker before. This is just the fun magic in the background, but hopefully, I'm coming in a little bit clearer for you today. I have some other changes I want to make here, but first of all, I should probably start out and apologize. I didn't set up like the pre-planned stream like I normally do. That was a mistake on my part. Sorry about that. So today is kind of an open animal. AJ may hop on and walk me through some AI stuff so you folks can learn with me tonight if he hops on. Otherwise, we can continue with the DLL hijacking and we can build out a more complete proof of concept, right? So we just did some fun little pop notepad, but we didn't really see that. We didn't see the full attack chain where we get a shell and all that fun stuff. So maybe that's something we'll look into, but we're pretty open today. So I see we got someone in on Twitch. Hello, welcome, welcome, welcome. Unfortunately, it doesn't tell me who I have in the chat, but say hello. Say hello in the chats. Feel free to pop some suggestions. But yeah, I've been exploring agent-based type, so agentic AI, all that stuff, a lot closer this week. So that's something fun I'd like to dig into. So maybe we do it on the stream and you can learn with me. There's been some fun chats in the community about agents, using Claude, using it to solve problems that we have at work. So there's some really good conversations. If you haven't joined the Discord channel, please do. Discord channel should be in every video that's up there, but it's also on the InfoSec Wizard page on YouTube. So check that out. Yeah. So what kind of announcements do we have here? What's new? What's new? What's new? So there is a new video out talking about walkthroughs. So someone mentioned it in one of the comments. Thanks for putting this out. There's a lot of stigma around using walkthroughs. So listen to that. If you feel any type of way about using walkthroughs, please check that out. If you've been watching the stream for a while, you'll notice that sometimes labs just don't work the way you expect, or the questions maybe even not asked well, so those can cause issues. So walkthroughs are good. Walkthroughs are not crutches. Walkthroughs doesn't mean you don't know what you're doing. They can just help you learn faster when used the right way. So check out that video if you want to know all the reasons why you're still cool if you use walkthroughs. How about that? All right, so, dude on Twitch, what do you want to do? Do you want DLL hijacking stuff, or do you want to start trying to figure out how to do agentic AI stuff and build out a cool multi-agent system? I was planning on building a multi-agent system to help expedite what I do for content creation. So, like all those fun descriptions, titles, editing videos, finding shorts, coming up with a strategy, building out a brand, all that fun stuff that goes into being a content creator, you could use agents for. It's a really good use case, actually. So we could do that. Let's see. I don't know if AJ comes on. We'll switch gears some. So why don't we dive into get something fun up front, right? Bluff. Let's get some up front. Let's go through DLL hijacking one more time. I was planning on doing a separate video for this for folks. So they can hop in the lab and redo it without watching this full stream. So let's dive into that. Let's redo DLL hijacking. So talk through it a little bit. And then we'll also build a proof of concept where we get a callback and get a shell on the Windows system as well from the DLL hijacking. So like I said, a much more complete example, and maybe we can explore. We'll do some Googling, see if we can find better ways to catch this, maybe even improve our sysmon telemetry while we're at it as well. So there should be some module loads that we can turn on that will catch some of the stuff without us going to prefetch. So let's dive in. Let's party. Who's ready to party? All right, so let me find the screen I need to share. Should be this one. Cool. And let me move Riverside up to the top. up here, get it out the way so I can watch chat for when anyone wants to talk. All right, cool. So DLL hijacking, what is it? If you didn't join us last week, we talked about DLL hijacking. And I don't like how this is doing it. Let me change the layout because I think you're still looking at me. There we go. Perfect. Okay. So DLL hijacking is essentially, there's a handful of techniques that fall into that. So we have search order hijacking, side loading, proxying, and there's a few other variations as well. And the idea is essentially that whenever you spin up an executable, it's looking systematically and it's done by Windows rules, right? Or the coding, you can hard code some of the stuff in there, but it's looking based on the Windows rules of where to find this DLL. And the trick is that an attacker with the appropriate access, right, they have to have access to those directories where it's looking. They can slip something in there and then it will load that versus the intended DLL. Now the power of that, if you don't know, is that if you control the files that it's loading, you can hijack the execution flow, right? Fancy word, meaning you can get it to run whatever you want to run. So you can give it a malicious DLL and tell it to run absolutely anything that you want, which is why it's such a great persistence mechanism. So if you haven't checked out MITRE ATT&CK, a really good place to check out. There's also the attack chain that you could look at as well if you're not familiar with the term persistence. But if you are studying to be a SOC analyst, this is something that you need to understand. What is persistence? Why do attackers care about persistence? And the key is that workers often work pretty hard to get inside an organization, and persistence allows them to persist, to stay in the organization, even surviving reboot, right? So a lot of the things you learn early on in your studies as a pen tester are just ways to execute and get a shell, but not necessarily ways to persist past reboot. So when you reboot, right, you restart all your processes and all that. And if you don't have a way to kick your shell back on, you have to go through all that steps that you did before to get access. You got to do it again. So persistence allows you to stay on there. And typically one of the first things a threat actor will do is after they get that initial access, that's another phase, they will then seek to get persistence because again, they don't want to lose that access. They want to retain that access. And so they'll typically do a couple of persistence methods. So if one's caught, they'll stay in there, or one breaks, they have a backup. So just keep that in mind. Persistence is very, very key, and that's typically something you'll see when you see a real attack, that they will have persistence most of the time. There could be cases where they don't care, like if they're just in there to smash and grab, maybe they don't care, but for most cases they will. Even in those, even when there's a smash and grab, they like to stay in there because they could always sell access later or come in there and do other stuff. So something to keep in mind. All right, so you're probably thinking, Mike, shut up, show me this thing again. Okay, let's show you that thing. So one of the tools that I chose to use here is Slack. It is very, very common in most networks. And what's great about it is that it's common. You can hijack the DLL. And every time someone pops on there and wants to communicate with work, they're going to be able to, they're going to launch your payload again, over and over, every time they start it up. So let's go through it one more time and we'll see that it executes. So it should, if not, we'll run it a different way here. But we should see Notepad. The payload here is just to create Notepad, and it's being a little silly right now. Here we go. You're going to execute. There we go. So we see it executing 3 times, but this is all our payload is. Simply just create a notepad and then put this in it. I don't know why we had Nordstrom. I think we were looking that there was a Nordstrom hack or something to that effect. That's probably why we did it. But yeah, so it just pops up, puts this in the notepad, and that's it. Now, that's why I was talking about we can progress that attack and do a complete attack chain by, instead of just doing notepad, we can do a shell, have it kick off a shell. So think command and control, if you've ever heard that. So a lot of times people don't know what shell means, especially starting out. But a shell is just simply what an attacker calls the ability to have a remote interaction with a host. That's all a shell is, the ability to execute commands on a compromised system. That is a shell. So in this case, we don't have a full shell. We just have code execution, another fun keyword for you, and that's it. So let's look at the code to see why that is the case. So I'm going to close this out. This is a different tool we were running, and we want this. So this is our code, and this is a DLL proxying attack, also a search order hijacking, because we do abuse the order that it's searching, but we also proxy all the function commands to the real DLL. And the reason we do this is because we'd have a crash if we didn't do that. And I demonstrated that last time, and I'm happy to demonstrate it again. But basically what it means is that it will crash because binaries, software executables, access DLLs for specific functionality, okay? And when that functionality isn't there, it will cause the program to crash that needs that functionality, right? In this case, Slack is accessing version.dll, and it's looking for specific exports. When they're not there, it will then crash because it can't continue with its code execution. So that's the problem. That's why we did the DLL proxying. So let me show you what that looks like really quick. We'll close out Slack. Every time it calls version.dll, it will continue to run our payload. Again, that's why it's so powerful. All right, so don't save. Let's close all these out. Don't save. Okay, now the trick. So we need this. This is going to execute Slack for us, or where we need to put it. This is our file that we need to drop in there. So version.dll. It also exists here. This is our malicious version. And we'll just drop our new one in here. Now that it's in there, it will call it and it should crash. We should see an error where it will specify a specific function and a specific DLL that it's trying to access. Right here, boom. I don't know if you can see this, but it's asking for, it says, hey, slack.exe has an issue getting to get file version info size W. Couldn't locate it in the DLL. So dynamic link library, DLL, that's what it stands for if you didn't know. So that's the crash I was talking about. And that's why we want to proxy the DLL, because we want the users to continue doing what they're doing, right? If we didn't do the proxying, what's going to happen, right? If your user and this issue happens, one, they're either going to look into it, maybe, but what's more likely going to happen is that they're going to say, hey, my version of Slack is jacked up and I'm going to have to reinstall. When they reinstall, guess what happens to your payload? It's going to go away and you lose your access. So especially for your more sophisticated actors, they want to blend in as much as possible into what's going on the system. So something to keep in mind. All right, so let's get back to where we were. We're going to revert the changes that we made. So we're going to put this in here. We're going to save it. And we're going to just make sure it's working. And then we are going to modify this DLL to start executing other stuff for us. Sound like a plan? And for those who've joined us last week, this is probably just a review, but it's a fun review. As we progress what we're doing, it'll be good to know, good to reiterate for you as well. All right, so this is done. Let's go ahead and rebuild the solution. And then we'll just need to do the copy. And we could also automate it. There's a bunch of automation we can do here as an attacker, but we're just doing very simple examples for you because that's all you really need. All right, so we're going to run Slack. We should see Notepad pop up and no errors if it worked, and we did. Beautiful. So let's go ahead and close it out. All of them. All right, was that all of them? That was all of them. It was only 2 this time. All right, now we want to talk about improving our situation here. So I am going to make sure security tools are off. And the only reason I'm doing that is because we're just trying to get a proof of concept working. We want it to work. We, as an attacker, if we were developing this for a like real type of thing, one, we wouldn't use Metasploit, which is what we're going to use, but 2, we would replicate the target environment and then make sure our payload would work in there and not get caught. So there would be a lot more steps. You want to get it working first in the most basic sample, and then you continue to develop it, the sophistication as you need to, right? We start simple, we get complex. You don't want to start complex because you're going to have a lot of issues doing the dev early on. So if you've ever had a programming class, right, what happens if you go ahead and try to do all the code? And I did this as a super baby programmer over 10 years ago. I guess it's almost 20 years at this point. But what happens when you try to just write all the code without even doing any testing, right? You write, say, 5, 6, 7 functions. You've never even done a build in a test execution. It's going to break. It is almost guaranteed to break on you. But what you typically do is you write and build one function at a time, checking along the way, having various tests to ensure it's doing exactly what you want as you continue to add layers and layers of sophistication to that program. Same thing with Malware Dev. That is the exact same thing. So lower complexity is always better. AJ is texting me. Let's see what he's saying right now. He's still goofing off. One other thing we're going to do that I'm going to coach you into doing is that I like to build in checks into my payload as we're building it to know at what point it fails. So for me, it makes the dev cycle a lot shorter by adding tests or printouts or creating logging for our execution. And then if, of course, we turn it off in the final piece, but it just makes it a lot easier to fix and correct things with it in there earlier on in your dev cycle. So let's bring up Notepad and talk through what exactly we want to do. So again, C2, and I've said this on a short before, C2 is literally limited by your imagination. We could build anything. We could build a C2 where it checks Instagram or TikTok or LinkedIn for comments and commands. We could do anything. Seriously, it's limited by your imagination. So the question is, what do we want to build? And I always encourage you to kind of do pseudocode. You may have heard pseudocode in a dev class. It's really good because it helps you structure your thinking and understand how your code's going to execute and what order you need to build things. Again, even more helpful when you have a much bigger, more sophisticated program. Welcome. If you're just joining us, I see someone joining us on YouTube. Welcome. Say hi. Say hello in the chat. We are about to build maybe something cool. It depends on your ideas. While we're building out this payload, feel free to add suggestions in the comments so that, or in chat rather, and we'll see if we can't build them into here. All right. So the first thing is we want, let's see, we probably want it just to execute maybe another binary. We could do, say, execute a Metasploit exe. Let's do that very simple. then maybe we can build off of this. Maybe we can encrypt it, so we can build in a decryptor that then maybe does reflective loading or something to that effect. But let's start with, let's just execute an exe, and then we'll build on to how complicated that is. So first off, again, let's go ahead and just make sure our security's off. And what's fun is we can actually check to see if our stuff actually works later on with it. But for right now, we're just going to make sure it's off as we do testing. So real-time protection is what we want to make sure is off. You also want to make sure if this is, see, it just told me it's off now. You also want to make sure you take a snapshot before you do anything crazy. We shouldn't be doing anything crazy because we're coding it, but if you're having ChatGPT generate a bunch of code, it may do something crazy. You don't know. So just keep that in mind because we will be using ChatGPT. All right, so we have our AV off. Next thing we need is we need to go into Kali and get a payload, and we also need to start our listener. So we could probably do like a netcat listener, something simple, really small C2. It really doesn't make too much of a difference, I would say. Let's close out of this. We're not doing any of that today. Let's see. Let's close all this junk out. We got lots of crap open over here. Man, this is how professional I am. I just leave up all these artifacts from previous work. Boom, boom, boom. Let's close it all. We had something running there. Don't know what that was. And this is the VPN. Okay, cool. We don't need to be on the VPN. We'll close that as well. All right, so let's close this out. This is going to chew up resources. Also, FYI, if you didn't know, any of these proxies, transparent proxies, they eat up a crazy ton of resources. So you need it, if you're doing them in a VM, you need to make sure you give it enough resources to run. All right, that's the random segue of the day. Hey, thanks for joining. If you're just joining us, see quite a few people popped in on YouTube. We are going to create a more complete POC, so proof of concept for our DLL proxying attack, and we're going to continue to iterate tonight until AJ hops on. If he hops on, he might just get with me later after all this to do some playing. But yeah, we're going to do some fun. So I want this to be as interactive as possible. If you're watching, feel free to add some comments. What do you want the payload to do? So you can think about this as malware dev. What do you want our malware to do? And we can start building some of that in. I don't think this will get me in trouble on YouTube, but we'll see. I'll try to keep it from getting me in trouble here. Okay, so as always, we're going to use Google AI to help me get my life straight here. Because I do it this way, so I do have a big notebook with all my commands and stuff in it, but I do it this way so you can see how you can do it yourself. You don't have all my notes, but you do have the same AI tools that I have, so I demonstrate it this way so that you can hop on here and build out whatever you want to build out, right? All right, so we need a MSF Venom command for a basic, we'll say, TCP payload for Windows x64. So this is stuff just that. Ooh, excuse me. So this is stuff out of my brain, but MSF Venom is a tool that will do the payload creation for us in Kali. TCP payload is just a basic payload we can catch with netcat. We could do a meterpreter payload, or as my dad calls it, meterpreter, which is hilarious. I don't know if anyone else calls it that. And we know we need it for Windows. We do want it for x64, so 64 bits. So these are very specific things Windows payloads won't work on Linux. Linux won't work on Windows. 64-bit payloads won't work on 32-bit, but 32-bit should work on 64. So some fun trivia for you. So we just need to make enough specification so it can provide us a command that we need to create our payload. So we got one. What we'll do is bring it over here, and then we'll just update stuff. So we do want to reverse TCP. So if you didn't know, the difference between a bind and a reverse payload are very different. A bind payload just sets up a listener on your target system, so your victim, and it's waiting for connections. This doesn't work so well if it's on an internal network behind a firewall. It becomes very difficult because you don't have any way to punch through that firewall. A reverse payload, on the other hand, goes from the victim and it calls back to you to whatever your attack server or attack system, wherever it's at. This allows it to traverse firewalls a lot easier, right? So if you have a web server sitting on the internet, which is very, very common, right? It will easily connect to those without a problem. So that's why typically you'll see a lot of reverse payloads versus bind payloads. And you may try to do bind payloads early in your career, early in your pen test studies. And I think just about everyone shifts to a reverse type of payload. So just some random trivia for you. All right, so now we need to come up with a port. So if we want to simulate a web server, we'll just do port 80, right? Now we need our IP address. This is very important so that it knows where to go. So we'll say if config, and we'll give it this payload here. And this should be exactly what we need. And we'll just modify this. So now with this, it'll just call, oh, it is a interpreter payload. Well, I guess we'll have to stand up a interpreter listener, whatever. It won't say interpreter if it's not, but that's fine. So what it's going to do is create a interpreter payload that's going to call back to our Kali box. We gave it the IP address so it knows where to find. We gave it a port so it knows what port to connect to. The TAC-F is saying what format. We want a binary, we want an executable. And then the TAC-O is obviously what file name do you want it to be. So we don't really care about this. This we do care about. It could be anything, but we're just going to call it from our DLL. So we just have to keep that in mind. So let's go ahead and do this, and we're going to execute it. Let's see, we'll call it, I think we created a folder in here somewhere. If not, we'll make one real quick. So we'll say make dir DLL payload cd DLL, and we'll do it right here. So now we'll run this. It'll take a minute to do its thing, and then it'll create our payload. So 510 bytes is the payload. So this is the connection piece. The final size of the file is 7,168. So there's a lot of other stuff that goes in there in order to execute it. If you're curious about malware dev or shell coding, any of that stuff, definitely encourage you to look it up. There's lots of really fun books, lots of good resources now. Didn't used to be. Now there's a lot. I think Now Dev Academy is one of the ones for malware dev. Very cool stuff out there. All right, so now we just need to be able to transfer this payload to our system. A lot of options here, right? If we're in our own environment, we can copy and paste. But I encourage you to think more like an attacker. How would an attacker get this payload onto the victim? Well, a git command. So think about it. Click fix, that's what they do. Typically, like if you're doing like a rubber ducky, any of those emulators usually have a download type thing. Pretty much anything does typically some sort of download from a server somewhere. Because typically what you'll see, even with malware, even with phishing, it's usually a multi-stage payload. You have a very simple one early on, then it pulls down a more complex one and executes it. So with that, what we're going to do is we're going to do a Python simple server tag m, just like this. So we'll do tag m HTTP server, so that's the module we'll load, and then we're going to run it on port 8080. So that's where we're hosting our web server. Now what we need to do is we do need to stand up a Metasploit listener. Sorry, sudo su default stuff here, MSF console. So MSF console, this is how you get to Meterpreter. You do have Armitage and some other ways to do stuff, but we're just going to use a simple command line because, well, that's what I'm used to. PS, let me know if you need me to zoom in or change anything so that you can better understand what you're looking at here. Also, PS, if you are at home on a laptop or any type of computer, let me know, follow along so that you get some hands-on stuff. I definitely encourage you, if you're not getting hands-on experience, you need to. This is how you do it. You play in a lab, you experiment, you learn stuff, okay? So now we're going to use exploits multi-handler. This is the handler for our payload. And what we need to do to create it is that we need to use a lot of the same options here. So there's a way to build this into Metasploit. I've actually never learned it, but we could learn it real quick. I just always do it separate for whatever reason, just because that's... shoot. Here we go. Sorry, I just do it that way. As you learn stuff and it works, you just keep doing it that way until you need a reason to change. So, whatever. Let me show you options real quick because I'm going through here setting things, but I want you to see what we're setting. So, these are all the options that we can do, right? So, we just modified this. This is going to adjust our options a little bit down here, but we need to update this and we need to update this to what our payload is. So now we'll set lhost to F0. So this is the normal interface for our Kali instance. And then we're going to set lport to, what do we say? Not 8080, it's just 80. Okay. So we'll show options one more time just to make sure everything got set properly. And as we can see here, it should match our payload. So here's our listening host. Here's our listening port. We should be good. And this matches exactly up here as well. So now we can just say run. What this will do, it will continue to listen for a connection until we tell it to stop. And so whenever our system calls back, it should work. So the first thing that we're going to do is just run this payload on our victim to make sure it works. And we do this again, we want to baby step our development process to make sure things are working all along the way. And the reason why we're just going to test the executable first is that if our executable got screwed up, and it happens, it could be like the transfer, something got lost in it, could be anything. But if we're sitting there troubleshooting all kind of stuff in our DLL payload, and it turns out to be our executable itself, we wasted a lot of time and we were actually troubleshooting the wrong thing. So we want to check everything all along the way so that we can narrow our troubleshooting down to less items and overcome those obstacles much, much quicker, which I promise you it will be. So rushing will get you into trouble. Eventually, you will learn to stop rushing. That is what I will tell you. You will spend weeks trying to figure out an issue, and you will learn, and you will do it another time, probably. And then eventually you'll stop doing it because you learned, finally, how to become more efficient. Okay, so I need this. So we'll go to Edge. We'll see if we can download this. We'll download it. It blocks us. Commonly download, make sure you trust the payload. keep it. Sometimes in the browsers you run into issues, but even with the AV turned off, but it is what it is. It looked like it took it, which is fine. So now what we will do is we will execute it. We don't need this anymore. We should see our payload. So we'll just double click it. That should be all that it takes to run it. We'll run anyways. And what we should see is that this is it downloading the payload right here. Then we should see a connection, and we do. So get UID. So this is the system. So it works. The payload works lovely. Now what we want to do is to now integrate it into our DLL execution flow. So we'll go ahead and background this. We can keep it around. We'll hit run. Listeners listening again. Great. So now what we'll do is, we'll work on our execution flow here. So what we need to do is we have the DLL here, and what we want to do is modify the code here to get it to say, just run the executable. And we can do that. We could even actually do it to pull down and then run if we want to, but let's just do it, have it execute we'll just have it execute the binary first, and then later we'll have it pull, then execute, okay? So let's ask ChatGPT, or whatever this is, Gemini. Where are you at, AI? Where is it? Oh, this is Bing, that's why it is, jeez. No one likes you, Copilot. Okay. Let's see. C++ code to execute a .exe file. So it could just be something super simple. So it could just be this. All right. Let's take this. We'll take it over here. And what we can do is we can comment this out. Actually, we could just add our code right here, WinExec. So we can do this. Do this here. Now we probably need to give it the path. So let's find the path. We need the full path, probably. So we'll take this, we'll add it here, and then, what was it, payload.exe? So we'll modify this. And notice that it's looking a little funny right here. It's because we need to escape these backslashes. Because the backslashes are escape, so we have to escape the escape so that it reads it intentionally. All right, so I'm not going to mess with this. I don't remember what it does. It probably just shows it, which is fine. We'll run this. So we'll go ahead and build. We got a lot of artifacts in here, which is fine. We should just see the payload execute at this point, and we should see a callback. So we'll build solution. Make sure there's no errors. Build is complete. It was successful. So we'll go into back into here. We'll go ahead and copy. Then we'll go into our app. So we'll remove this DLL again. Yep, it went into it. Oops. We'll delete the DLL. We'll paste our new one. Now here's the fun part. Now, what we expect to happen, and I also encourage you to get comfortable with predicting what's going to happen, because if you can't predict what's going to happen, you're probably going about writing your code, doing your stuff wrong, because you're just going YOLO, and YOLO isn't learning. It should be intentional YOLO. How about that? All right, so now we should run When we run Slack, it'll run our DLL, which will then run our .exe payload, which will then connect back to Kali. So these things get complicated quickly. This is why we do it one simple step at a time, slowly increasing the sophistication of our steps. And for me, some of my long attack chains, I'll have them diagrammed out, like pseudocode, graphed, everything, so I understand exactly what's happening. Because it helps me figure out where the flaws are and why stuff is breaking, because stuff does break. All right, so shut up, Mike, run Slack. All right, we've run Slack. We'll wait for Slack to pop up. It should pop up. It should pop up. Maybe. Might pop up. Let's see. Regardless, we have a connection. I don't know why it didn't pop up. Maybe it's running in the background or something. It's starting up. It looks like it's doing some stuff here. We'll give it a second, but we do have our connection. I'm just confused as to why Slack did not indeed start up. Let's try it one more time. And we'll background this. Oh, didn't spell it right. Background. We'll run. Oh, it's just running steady in the background. Maybe it's a, maybe it can't finish because it's blocking it. Could be where it's blocking, because remember we saw it execute twice. See, there it is. So it is working now. So it has to execute a few times. So we could probably fix this by doing run dash J, I think is what it is. I forget what it is. Let's see. Metasploit handler continue listening for connections. I forget what it is because I don't ever use it. Set payload. Let's see. Let's modify. I want it to keep accepting connections after the first one. Let's see. Exit on session, no. Well, let's see. Let's see what happens if we start it again. J might have been it. We should see it actually start up if it's doing what we think it's doing. Question is it? Welcome. If you're just joining us, feel free to add comments in chats so that, one, tell us how your week's been. Two, we're building a more sophisticated DLL hijacking payload. Feel free to drop some suggestions for me. What is it? What is it? What is it? So we have 5. And what I'm looking for is I'm trying to remember how to keep it listening. Run persistent job. Use -J but I don't think it's working the way we think it's working because we're also not getting another connection now. I don't know why. Oh, there we go. Now it's working. So there was just something running in the background. We should see 5 completed, maybe. But this is a good question. So with our payload, while one, we shouldn't expect to see a bunch of connections at the same time. Well, maybe with phishing, but we do want to figure out how to handle these different workflows, right? What do I do if it comes at me multiple times? Do I want more than one connection on a single host? Things like that, right? Because with our DLL, right, it launches multiple times, so we do need to consider how do we maybe modify our code to only launch once. And we could do that in a few different ways. We could say, hey, look to see if there are any other sessions running of payload.exe and then only run it once. But then that'll break. If we do like an encrypted payload, that may break it as well. Yeah, I thought it was right, but it's acting goofy now. Let's do it one more time. Let's see. So we should see a payload 6. I think Metasploit's just being dumb right now. Let's look at jobs. No active jobs. So it definitely isn't running. What was it? Jobs.z, I think is what it was. Now I'm getting mixed up. Job-jz. Let's try that. So we'll do run.j.z. We'll probably see some connections, which we do off the bat, 6, 7. Cool. They should be connecting in the background. All right, so that's working. We should see, there's Slack here starting up. All right, so we do have that. All right, so we got kind of a proof of concept working. We're getting the DLL executing our .exe. And now what do we want to do? Hey, Jarrett, welcome to the chat. Thanks for dropping something in there. Let's see, what do we want to do? Do we want to add a check so that it only runs once? We could do that. It is running a little bit slow, so that's something interesting. What we can do is say, let's do that. Let's kind of talk through the code we want to execute here. So we can say, so step 1, DLL runs. Then we want it to say, see if payload.exe exists as a process. If yes, do nothing. If no, execute. So let's do that. So if we can just take this route over to this and ask it. Let's say we say, I want C++ code to do this. Probably should have took the DLL runs thing off, but that's all right. So here we go. We're using a Win API. Yep, we're using a Win API here. It's going to do some stuff. This is going to be some fun execution here, but we really only need this piece here, right here. The is process running. We already have the execution piece. And we could probably improve our payload further by dealing with that. So let's see, we may need, looks like we have some stuff missing here. So we may have to add some definitions to the top for it. Right here, we'll add these. Looks like we have some of them. This is a duplicate. There we go. All right, so this is in here now. Now we can call it. And so we need to make sure. Hey, Philippe, welcome. Welcome back. And then we need to say DLL attached. Here we go. We'll add this to our code. If you're just joining us, we are making our DLL hijacking payload more fun. I guess that's the best way to describe it. And we are going to want it to we'll comment these out. We want it to we want this one. This is what we want. This is our execution. We'll take that and we'll modify this. All right, so what we've done so far is it's going to check to see if payload.exe is running. If it's not, we're going to execute it. Otherwise, we're not going to do anything. So we should only see it execute once. All right. Woof. Hope you're having a good night, Philippe. And a good week. Thanks for hopping on last week. Let's see. We'll rebuild solution. We have a success, so we're good to go. So what we need to do is now we'll get rid of this. Now we need to modify our payload. Well, not our payload. We need to copy our new DLL over. Close that. Just clean it up a little bit. All right. So now get rid of this. We'll drop our new payload in here. Now what we're expecting is that hopefully we have a new session open, but we need to close out all of our other sessions. So sessions -k1. I don't remember how to do all. There's probably a all on here. Let's ask chat. Is there a way to kill all sessions? Okay, cool, easy. There's always a way. Someone's always figured out how to be lazier. There you go. All right, so let's check sessions. We have no sessions. Payload.exe shouldn't be anywhere. So it should run now. The reason why we got rid of those is that if we ran our code, payload.exe exists in a process and won't work. So we need to make sure that it is indeed not running, because there still could be some stuff hanging out waiting on us. So we'll just go down here to the P's. We don't see it running, so we should be good to go. All right, let's run Slack, and we should see payload.exe pop in there. We did, and we should see a session. It didn't connect, so I'm wondering why it doesn't stay persistent. So the job doesn't last forever. So that's kind of interesting to me. We'll say run. There we go. Now we have a new session. Exit. I just want to make sure it's working. So, excuse me. So, all right. So it's here. It's running. And we'll close that out. We'll make sure we don't have a session. I should put these up in like dual screens or something like that. All right, we don't have payload.exe running anywhere. So we'll run it one more time and we should see only one connection occur. We have a session and we have Slack running. Okay, so it's a little bit smoother now where we only get one instance of our payload, right? It'd be pretty suspicious if we had a bunch of something that we shouldn't have a bunch of something of in the task manager. And also a lot of executions for our SOC analysts out there may be able to find this a lot easier. So we do need to be careful there. All right, so next question. How do we make this even sneakier? That's a fun one. So we could do a reflective payload. We can do, oh no, we said we were going to do a download and then execution now. So now let's add that to our situation. So let's revise what we want it to do. For some reason, we still have it doing all the print a notebook. Open notebook, what is it doing? Open notebook. I'm looking to see if it's anywhere in here. We shouldn't be seeing it anymore. Man, everyone is hitting me up while I'm streaming tonight. They'll be fine. They'll be fine. All right, so I want to run it again to see if the notebook opens. I don't know why it is, but I do want to see why. So we'll exit. We'll run one more time. And again, we're just checking to see if the notebook opens up because I don't really understand why it's doing that. Just to be fair. So it's opening notebook, but it shouldn't be. Okay, so that just must have been an artifact from before. Okay, cool. We have a connection here. Let's go ahead and exit. Exit, run. All right, so we have it listening here. Close this out. We'll just double check one more time because sometimes it may kick off another one if it's called again. Let's take a look at chat. Philippe's in here chatting away. So I guess I'm planning on the CDSA instead of BLT1. Why is that? Did they convince you in chat not to do it? There's a big conversation in our Discord channel this week talking about which blue team certification is better. Is it BLT1, not blue team? See, you messed me up. It's blue team level 1. See, you do it too, Philippe. I always say BLT as well. And people are joking that it's because I'm hungry, and that could be so, but it's blue team level 1, not bacon and lettuce tomato 1, versus CDSA. So if you do finish this, Philippe, please give me an update of what you thought about that one. Both of them are good. The criticism from Blue Team Level 1 was that there was more forensic stuff. That is a fair criticism. Some SOCs, a good bit of the SOCs don't do any forensics. The SOC that I run at the moment, we do cradle to grave. So people are expected to know some level of forensics, and we give them a lot more room to do malware analysis and all the other stuff. So it makes sense for those type of SOCs. So cradle to grave is the word. But for most, especially if you're a tier 1 SOC analyst, they don't care about the forensic stuff. But I think it helps add a little bit of dimension to understanding how all the pieces work together. But it's definitely not necessary at that early age, or at that early stage, age 2, your security age. All right, so get back to dev time. Let's open up a notebook, and what we want it to do is we want to say check for payload.exe. If not there, for payload.exe process, we'll say, if not there, we'll go classic. We'll say, if not there, Then we're going to check Windows temp for payload.exe. Or we may not even care. We may just want to override it and run it. Let's not do that second check. I'm just thinking in my head how to reduce the number of steps. So we can say, if not there, download to temp download the temp and execute payload.exe. Okay. So now the only thing we need to download or to do is we need to do the download function. So we need to ask AI to say, hey, how do I download files with C++? Then we add it to the structure we already have, and we're in a good spot. So let's do that. Oh, we're getting a bacon, lettuce, and tomato isn't up to date. CYSA covers areas, and it's a bit more challenging. Cool. Yeah. Sounds like fun. I don't really think you can go either way, but I would definitely say go with the most up-to-date stuff whenever possible. There are definitely a lot of courses out there that don't stay up to date for good reason. It's really tough to stay up to date in the world. So, yeah, sounds like fun. Now I need code to download a file from a download, we'll say download payload.exe from, we'll say loopback. And we'll just change this later because I don't want to put my IP address in here. Let's see, is process running? That's ours. Here's our download and run. I want a function that only downloads. I guess we could do that by just modifying this. So we'll just take this and play with it. We'll take this, but you could definitely have it continue fine-tuning things for you. So we'll do this, void download and run. We'll just modify this to void download, and we don't need this piece. And so what we want it to do is we probably need to give it a path. So the destination is going to be, we'll say, we might be able to do like normal pathing in here. I can't remember. Windows, temp, payload, and then we're going to have it execute. Let's see. We'll modify this to just be like this, and we'll fix it if it doesn't work. How about that? All right. So what we need to do now is we also need to, we can modify, we can say execute. Well, what we'll do this the fancy way, right? So we should be, this is called refactoring. So what we can do is we can just change this to execute, and it should refactor it for us. So you can see down here. So if you didn't know, refactoring is a fun way of just editing your code in one shot. So instead of having to go line by line looking for like function names or whatever, refactoring does it all in one go. So any reference to that, it'll go ahead and update for you, which is fantastic, right? It makes life quite a bit easier. All right, so the other thing we need is we need to do this. Here we go, and we need to update this right here. Awesome. So Jarrett's in there. So definitely feel free to give him some tips on studying, Jarrett, if you got any for him. Philippe's killing it as well. He dives in and learns a lot. He's always doing something. All right, so we've updated the URL to be our system, right? And what we want to do, so we have our handler running. We also probably want to clear this just so we can see if a new connection is made, right? Because we should see a connection, then we should see a new shell on the execution side. So let's go ahead and do that. We'll go ahead and build the solution. Looks like there are some errors here. I may have forgotten to add something. Oops. It's probably IO stream. Probably one of these. Let's see, and we'll just get rid of duplicates. All right, there we go. Let's try to rebuild. Oh, we still have some ugliness down here. Let's see, unresolved external symbol, URL download the file, one unresolved external. So this is our issue here, and we just need to be able to resolve it. I don't know what is required for. Let's see, can I copy? And we'll ask it. So there may be just something at the front of this. The Windows API calls are always funny. Here we go. This is what it was. This is required. So Windows APIs are always funny because there's a bunch of requirements, always a bunch of requirements, and you have to get it just right or it won't work. There we go. Now it's working. So we have success. We're good. And now we should be able to see if our payload works correctly. So we'll take it, we'll copy it. Now we can also by the way, we could also be using rundle to execute our DLL if we want. We could. Total choice. You could do that, or you can do it the way I'm doing it. Not much difference. I mean, if you wanted to automate your workflow with test cases, that may be a good way to do it, but totally dealer's choice on that one. All right, so we'll run this. We should see it run. We didn't see the download. We didn't see a connection. So it did not do what we expected it to do. And the reason why we do all these checks and we understand is because we know it didn't connect because it didn't even download. And now we need to troubleshoot why didn't it download. And should be pretty straightforward. Let's see, we're compiled, 2 or 3 compiled, the rest were copied from previous compilation. So we need to troubleshoot, and I think it was because I didn't add the download. That's exactly what it was. So we want to add download, and we'll do it right here. We'll just say download, add our semicolon. That should fix our issue because I'm an idiot and that happens. Although I got a nap today, so my brain's not as junked as it usually is at this time. So we'll copy this. So hopefully folks are learning a little bit about how this stuff works. Most people don't get this insight. They haven't seen Malware Dev, and it is a very slow, very tedious process. Like I said, you see how we're going back and forth. There's definitely things we do to automate some of the workflows. I just looked right into the light and it blinded me. There are ways we automate our workflow to help with some of this dev. We definitely also, for people who, I don't want to say more mature, but who are more dev of a background, will include test cases to ensure everything's working so that you can catch problems earlier. There's a lot of things that you'll see, but all around the dev process is slow. You're constantly tuning, you're constantly running it against your security tools that you expect to encounter in the client side or target victim area. So lots of things that go into this. All right, let's go ahead and see if we get execution. We should see something pull. Hopefully we should see files pull down. There may be issues where like the download piece isn't working, and we can really focus on resolving those issues, but it should be working. If we see Python working, let's see, we do want it to check first though. So we have it just straight up downloading to see Windows temp. It should be attempting to pull it before writing. I'm trying to troubleshoot in my brain where it's breaking. Like I was thinking maybe the way we're doing the structure for the path may be wrong. And it could be. But we're not seeing it come up at all. Let's see if Slack is running. Slack is not running. Let's check. Let's check here, see if we see Slack at all. We have Notepad up. Slack is running, so it's like it's waiting for something. So I'm not sure what's holding it back. But something is obviously holding it back. Maybe we can rethink about our code situation here. Let's see. So we have this. What we could do is maybe change the path to be more correct. Because sometimes you'll run into issues. I thought you could do it that way, but it may just be like C# or something. So let's try it like this. Oh, it never executed. Well, it should, actually. I want to take this and put it under here. And we could also be a little bit more extensible with our code by taking a parameter in both of ours. Instead of hard coding it here, we could do it down here or do it more dynamic. Definitely have options there. Let's go ahead and rebuild this and try it again. All right, let's go ahead, and what we're probably going to have to do is terminate Slack and then retry it. is actually being used currently. So let's terminate Slack in task, easy. Get rid of that, paste. If there's a handle, you can't delete stuff. So fun, fun, fun. All right, so let's just make sure nothing executed over here. Did not. I want to, can I detach? Can't detach, sad face. I thought there was a way to do that. All right, so we're good here. Let's go ahead and restart Slack, see what happens. So we're running Slack. We see it running here. We know it's trying. We don't have that yet. We don't have a call. So there's definitely an issue. Definitely an issue with our download piece. So if config, let's see if our IPs have changed. Let's see, so it should be 113. I've had that happen to me before and it's very annoying. Nope, this is correct. Okay. So what we can do, is, I don't know if we can execute this in here. We might be able to. Yeah, I didn't think so. I was gonna say we might be able to transfer this to like a C++ file and then do some of the execution. We need to figure out why this isn't working. What I think we'll do is we'll comment this stuff out. And we'll just have it try to download right here. So super simple, just download and see if it's working. I don't think payload.exe was up there because otherwise it would have avoided anything, but it's worth a shot to check. So we'll do that. One succeeded. All right, let's give this a whirl one more time. Again, I told you it is a very time-consuming thing. Processes got a handle on it. Let's get rid of it. I don't think payload.exe is running. It is not. Get rid of that. We'll do a paste. All right, so let's run Slack one more time. It should just simply be downloading. And that is it. Terminator? What is Terminator? I've never heard of that. Well, I saw the other day there was a quick key to split as well, and I already forgot what it was. I was like fat fingered it, and it worked great. It was something like, was it R? Nope. E? Nope. I don't remember. There's a quick key. Let's see. How to split terminal window. Cali. There's a way to do it with quick keys. Vertical split, Control Shift V. Let's try that. Control Shift V. Well, that didn't work. What is it? What is it? Oh, here's Terminator. Here's Control Shift E, maybe? I don't know what the key combo was. Let's see. What a shame. We'll never learn again. Sad face. Yeah, great suggestion. I had something before. I hate installing apps just for silly stuff like that. I know, especially if I know it's built in. I just don't remember what the shortcut key was. It is Control Shift R. There it is, Control Shift R. Got it. Okay. Boom, there we go. All right, let's do this. We'll take it over here. There we go. And we'll run those. There. Now we can see everything. Thank you for that, Jarrett. All right, now we still have to find the issue that we're having. So our download definitely isn't working. We know it's not a firewall issue because we're able to do it before. So there's just something in the way that we're calling the download that is not working. So let's see if we can't figure that out. And it could just be trying a different method. This does not seem to work. Let's see. Talking to blah, blah, blah. Method opens an internet session, connect to URL, and reads the file into a local buffer. So this is a lot more complex. Might be a lot more complex when I say path issues. Ensure destination string includes a file name. And that the folder already exists. So actually, let's check that. See, Windows temp payload. There may be some kind of case sensitivity. I thought it was all capital. So C, Windows, temp. So it does exist. So that's not the issue. Let's see, permission. If your DLL is running inside a protected process, it might not have write access. It should the temp. And we are sure the protocol match does work. So let's just try a new one. And I guess I can just pull all of this. We'll have to make sure we add quite a few things for this one. It's just sometimes things don't work. Things just don't work for whatever reason. So we'll do that. Now let's add this up top. I think we just need these two. Add these. No, we already got Fstream. How about that? Get rid of it. We should be good here. This needs to go up top. That should fix our issues. Should have. Oops, I don't want Copilot. Go away. Windows H, win it. That might be new, actually. Close, go away. No one wants you. That might be it. All right, so this might fix our issues and missing stuff down here. Okay. So now when we call it, we need to provide it a URL and a destination, which is fine. So we'll download file like this. The issue is we're going to need to make sure that we have the right data types for this call. And this is the tricky part with stuff like this, is that you need to make sure the data types are correct. And they're very confusing. They can certainly be very, very confusing when we're in C and these much lower level languages. Let's see. We can try just providing ours and hope they're in the right format. They may not be, but that's okay. So what we can do is take these down here. I hate putting it here, just to be clear, but that's fine. Now we need to know what order it needs to go in. So it needs to be URL, then destination. So we'll say URL, destination. And so the issue we have here now is constant tchar is not compatible with constant char. So this is where I mean like the types, but it should. That should solve the problem. I think we're good now. So I just fixed the types. And now we have issues. Initialization URL is skipped by case label. Oh my goodness. It's skip. We may just change the way we do this and modify. This may need to be done outside of the switch, perhaps. I don't know if this is going to break the way a DLL works. I've never tried to do this in a DLL. It worked. It didn't not like it. All right, so let's try this again. So we do need to terminate Slack. And yeah, Jared, if you need me to kind of go over anything, anything you may have missed, just let me know. I'll take a technical pause and get you caught up real quick. All right, we'll throw this in here. All right, so we should be good. We should be set up. We should see stuff happening over here in a second. So let's go ahead and start Slack. Let's come over here. And we're looking for something to reach out. And we're not seeing it. And the issue is I don't know where the problem is. And that's what we need to solve. Ooh, excuse me. It could be anything. It could be that there's a firewall in place preventing it from calling out. It could be something's goofy with the way it's accessing this connection. There's a lot of funky things going on here. If HInternet returns false, let's see, internet URL open. I wonder if we can, well, I was going to say we could get it to print, or we could get it to basically write to a notepad for us. Could do that. We can use our little print to notepad. Print to notepad and provide a function of what we want it to write, which could be the URL it's trying to access or something. Like we need to know what the data is that it's attempting to use, and if the data is bad, that's the obvious reason why it's not working. Yeah, we're doing a little Malware Dev tonight, just building off of a DLL proxy payload. So we need to understand what the data looks like. It may be easier to just make this a traditional C++ file, so we can just run it iteratively, and we can do some active debugging with it. So we might do that, and I'll show you what I'm talking about. Let's do. I want to keep this open, so let's open up another Visual Studio. We'll see if I have enough juice to do this. We'll see. This is a VM, so I might not. We'll start from console app. Next, we'll call it, we'll just call it test run. And yep, that's fine. All right, cool. So the only difference here is that we're just going to copy some of this stuff over. So we'll take this over here, and we'll put it in our new one. Let me actually just put these on the same screen. This is doable. And we'll do this one. Hopefully, let me know if you can't see my screen. I'll try to do some resizing so folks can see what I'm doing here. All right, so this is int main. And we will just add both of these download capabilities here. And we'll add all of these as well. All right, so we have that, and we also need, not that one, we're also going to need this. We're going to put that down here in int main. And then we're going to just have it do this. And we'll also go ahead and just do the download one as well. So basically the reason I did this is because we have some goofy stuff going on, and we could probably automate the debugging of the DLL. It's just not as easy to do. We could just build a C++ project and run it all the same and be able to do some debugging in here. That will make life quite a bit easier. But let's go ahead and just do one at a time and see if it's either a problem with the way we're doing it in the DLL or our code is busted. Either way, we'll have more data, and that will help us figure stuff out. So let's actually make this release. I sometimes have issues with the if I put it in debug, I sometimes have issues. So we'll do this. Exit with code 0. So let's see if we got anything. So that's something. So we did get a download. We did get a download. Okay, so I think I know what the issue is actually. I'm an idiot is what the issue is. We didn't tell it what to download. That is the issue. That's why I'm an idiot. All right, so we should see payload.exe. So let's see if that fixes our problem. What are you gonna do, man? What are you gonna do? All right, so let's try this again. Let's go ahead and terminate our Slack process. Stupid stuff happens all the time. I mean, it's not surprising. It's not surprising to me. It's too funny. All right. The demo gods have failed me this evening. I did something dumb, but you got to watch me troubleshoot. You got to watch me troubleshoot. And this happens to everyone. So if you haven't done a lot of dev, then you're missing out because this is pretty common. You'll just fat finger something, or you did something dumb like I did, and the logic is just busted. So this was a logic problem. Logic as in it went to the site and it didn't know what to get. Um, but that may not be the case because we didn't actually get any connection with this one when we tried it. But we'll see. We'll see if that is indeed the issue. Um, we'll give it a sec. So let's grab this. We'll copy this. We'll get rid of this, and we got it here. All right. So now let's run Slack one more time. What I do want to do really quick before we do that is, oops, I want to make sure this is running. I want to make sure this is running. It's a clean session. I just want to make sure that you can see when we do have a good connection. All right, and we'll run Slack one more time. We should see a connection perhaps. And we don't. I wonder why. So there's something goofy going on with the way the DLL runs the code, I think. We'll try a recompile, maybe. Or maybe we'll try let's see, let me look at our code here real quick. So we have, as soon as it attaches, it should reach out and grab it. And it's doing the same thing that it was doing before, where we didn't see this initial grab. So we saw this even when we didn't do, when we didn't have payload in it. It at least attempted to go to the site. So we're not even seeing an attempt to go out and grab something. So there's an issue somewhere. And it may just be perhaps the way we have it structured here. I don't know. Maybe let's try putting it here. And this should just straight up pull the file. That's it. So this is kind of the fun stuff. And this is why we do it as simple as possible. Again, like I had a very dumb error. And we probably spent, 15 minutes troubleshooting the error. But even when we fixed the actual problem, there's another problem that's there. So this is malware dev. This is dev in general. Okay, so we have a new build. Let's try to run it one more time. We just changed where it was executing. So we wanted to execute before the case. Okay, so let's go ahead and open this. We'll grab this. Our file should be released so we can delete it. We'll grab this one, which is a new compilation. And then we'll paste it here. Now we run Slack. And we'll see if it runs. And it's pretty simple. All we're doing is literally downloading a file. You can't really get more simplified than that. And it just doesn't like it for whatever reason. And the most interesting piece is, what's the difference between our C++ code here and this code here? Because we have constant char, we have the same thing, 8000 payload.exe, we have the same path, and we just run it. So it should really work for us here. Fun times. Let's try something slightly different. Maybe it just doesn't like, so like we could use print statements. What I was going to do is have it write to the notepad as it got to different things, because I want to see where it's getting stuck. It's getting stuck somewhere, obviously. And we just need to figure out where that is. definitely open to any ideas if you have some in chat of something else to check. I'm going to simplify this even more. So we're going to take this and we're going to put it up in, got something buzzing around here, up here. We're going to call it URL destination. We're going to get rid of it here. So it's not going to take a value. And that means we got to clean this up as well. So it's a little more simplified. Yep, that's exactly what we're doing, DLL sideload, with actual DLL proxying, because we're forwarding all the exports as well. So a little bit cleaner than well, not sideloading, it's more of a search order hijacking, this one. So like a more, I guess, a higher version. Let's go ahead and build this. I'm gonna do a full rebuild. Maybe there's something goofy going on. Okay, so we did a full rebuild. Let's make sure Slack isn't running. We'll end that task. Let's try it one more time. So this was actually supposed to be pretty easy, Jared, or Mag. We had stuff working. We had it running the payload. Now we're trying to do a full download and a download, then an execution. So we got the execution piece working. It's just being a pain. I don't know why it's being a pain, but it's being a pain. We will, hopefully, figure out why it's being a pain. All right, so let's run it one more again. And we should see a connection, which we don't. Interesting, right? Interesting. Trying to think why. So we could split this out, right? We could say, it just depends on the attack flow that we're thinking about, right? We could say, hey, you know, it was a phishing email, so, or a click fix attack, and we had them run something that downloaded the slack.exe, the version.exe payload, downloaded whatever our payload.exe is, and then it runs it like that. And so we wouldn't really need to do the download from the DLL. The DLL would just simply be the execution piece. That could be fair. We could do that. But let's explore just a little bit more in here, see if AI can help us. Run from a DLL. What is wrong? Ah, interesting. So it wants us to create separate threads. Okay. Let's see. I'm reading this to if UL for callback process detach, handle thread, create thread. Is this the same as ours? Let's look at ours. See what it's looking at here. If UL reason for call is DLL process attached, that's that one, then handle. So we could just put this in here, right here, because we really don't need all that fun stuff. And then we need to look at this background task. I don't know if it's different. So it's saying we need to give it a second to load the DLL. let's just drop this in here. I'm going to just be lazy instead of analyzing this. And we'll put it right here. And we want it to do, excuse me, got hiccups. We want it to do this. We're just updating this, so URL, pulling that, destination, we do need to update destination still. We'll split this out also, by the way, we'll split this out if we need to. Let's just try to get it to work first. All right, so looks like we don't have any errors in here. Let's turn this off, this one. We don't need that one. We just want this. The payload task is the one we saw up above. It's going to be doing it with threads, which should make it work better. Let's build it. Let's run it. Let's see what happens. Ouch. Initialization of HK by case label. It doesn't like something. So what's tchar? Let's take a peek, see what we're missing here, because there's probably just something missing at the top. So we got Windows, we got URL mon, do we have TL help 32, and we have tchar. And we also have URL mon.lib. So we have all of that. And we're just having issues with hchar. So let's pass that to it. Copy. I get this error. Let's see. Hey, Harem, welcome. Let's see what's different about ours. So we have our fun switch. We have our DLL process attach. And it says we need opening and closing brackets here for some reason. Let's see if that works. And that indeed work. How about that? All right, so we have our new build. Let's go through this one more again. We'll go ahead and in Slack, we will bring up our app. We'll get rid of that. We'll add this. Oh, we're just having fun troubleshooting tonight, Harem. I think you popped up in the last one where we were doing DLL proxying. On this one, we're just increasing the sophistication of our proof of concept and doing something a little bit more fun with it. And we're just trying to get the download piece to work by any means necessary. So we'll see. Maybe you're our lucky charm. Call your lucky charm, Harem. Oof, we got an error. Stack-based buffer in this application, this overrun could potentially. Let's see what happened on the Kali side. We got it. Okay, it works, but we got a weird buffer overflow thing. So we don't want the user to know that we're here. So we need to figure out how to get rid of this system error. So that's the next quest here is let's get rid of this error now. System detected an overrun of a stack-based buffer. Let's ask it. I wish I could copy this. The system detected, all right, good, it's sitting there. Got it to run, but got this error from the DLL. The system detected an overrun of a stack-based buffer. All right. The system overrun, error, blah, blah, is almost always a security check failure. This happens when a compiler detects that a function has overwritten its stack canary. Interesting. So I wonder where that happened. Most likely unsafe string operations. Let's see. Replace your current path handling with a safer, more modern approach that uses standard string. So let's take a peek and see if this completely screws up our stuff, like if we have to do more here. Oof. Oh, so it did actually crash Slack on us. Y'all see that? It crashed it, and now it's gone. So it did crash Slack. We don't want to do that. So we need to figure out how to solve that problem. We want to keep hidden. That's why we're doing a proxy. All right, so let's give us some more real estate here. So it should be, that's fine, all that's fine. We got a max, so there's a whole buffer stuff here. So it's just really changing a lot of this, actually. It's changing a lot of this. If succeeded, shall execute. Okay, so is that changing that at all? Okay, so we'll just take this, we'll update it as needed in here. They just completely rewrote this. What I want to make sure we do is just copy and paste all the things that we need to. So this is one of them. We need to copy this down here. And then we also need path URL. Where is here's the full path. So we need to replace that as well. All right, that should suffice. All right, so we should be good. We'll rebuild. Hopefully no errors. No errors. So we got a good build. Slack is off. What we do need to do is we can leave this up. That's fine. What we do need to do is exits, run this again because we need to catch our payload. So this is listening. So let's go back into Windows. All right, so this is fine. Let's go ahead and run Slack one more time. Are y'all having fun tonight? Are you learning anything? That's the big question. Is this new? Is this boring? What do you think about this stuff? All right, so we have it here. Who thinks it's going to work this time, or who thinks it's going to look busted like it did a second ago? What do we got? What's the over/under on this one? What do we think? What do we think? Are we going to be able to end on a high note tonight? Maybe. Here we go. Hold your breath. Womp, womp, womp. Stack Overflow issue still. Dang. And we didn't actually get a handle this time, so that's interesting. So we pulled the payload, we didn't get a handle, but we got the overflow issue. Boom. It actually was an even worse crash this time. Let's chat with it again. We got a few more minutes. Let's see if we can get it to work. Still crashes the process. All right. See, I will say it's a lot easier in GPT. It's way more efficient. Let's see. Try to write more data into the buffer. likely caused by buffer size mismatch or encoding issues while building paths. Now it's going to try an even bigger one. I don't see where it's adjusted the paths or anything though. Okay, so let's try this one. I don't know. I don't know where it's breaking. I don't know why it's also creating a snapshot there. We shouldn't have to do all that hard work. I actually don't care about is process running yet. Let's adjust it. Say just focus on getting the download and execute working. It should download the file and then run it. To resolve the persistent issues when running, you must use a background thread and a wide character code handles the download to Windows, which is guaranteed to be writable and executes. Where is it using is running? Do we see? Oh, it's down here. It's going to check to see if it's running. Let's see. We got 4 minutes. Let's just go YOLO here. Throw it in this DLL, see if it works. So we'll just make sure we take all that. And we'll go back in here. We will add all of these. And we will just update these full paths. Full path, where you at? This, let's see, this is it here. And we will just need to trim this off. Oops. Oopsie. There we go. That looks fine. And then we just need to update the URL. Wherever that's at, right here. All right, so that's fine. Let's get rid of this background task crap. We know this is working. I'll keep that execution piece there. We do need, this isn't there anymore, so we do need, let's see, is it just payload task? Payload task. So that should work. Okay, let's rebuild. Let's double check to make sure we don't have Slack running. We don't have Slack running. We should be able to easily copy and paste. Copy that. We'll get rid of that. We'll paste that. Okay, it's here. Let's go ahead and run it. See what happens. Well, let's just make sure Kali is working. Okay, good. All right, let's hit it. Same. Oh well. Well, we got it kind of working. The life of a hacker, getting stuff to kind of work. It doesn't work all the way, but it kind of works. But this is the fun of it, right, folks? This is the fun of exploring, trying to get things to work. There are other solutions that we could, instead of doing everything in a DLL, we could just do it in another file. So we could use the DLL to do a reflective load, and all that. So there are other ways to do it. I was just trying to be hard headed and force fit this in the DLL, but um, it's definitely better to do minimal in the DLL and just do the forwarding. Yep, I did export all the stuff. So I used Spartacus last week. Definitely recommend that. I don't think I have it up here anymore, but Spartacus did all the exporting. I'll show you real quick. Oh, we only had one error. We had nope. Sad face. I thought we had less errors. We have the same number of errors. Oof. Lame. I think I might know how to solve this problem actually, but it's time to hop off. Yeah, so I exported everything for version, and so this will send it to the real version. So it should work smooth. We shouldn't see all those executions. Sorry, not execution. We shouldn't see all those errors. That's why we did it this way. Jared asks, that was helpful. I've been doing some malware dev labs on my own lately, but I'm just getting into it. Do you do these every Thursday? I don't do malware dev every Thursday. Sometimes we do blue team stuff, but it's definitely cybersecurity related to some degree. Typically, when I'm a good boy, I'll put a description of what we're doing on Thursday, so that will help you, Jared, to decide if it's something you want to dive into. But definitely something fun every time. Sometimes we do purple teaming. So if we got this working, we're going to dive in and improve our logging so that we could detect the DLL proxying, DLL search order hijacking a little bit better as a blue teamer. So that would definitely be handy for you doing malware dev. But yeah, so just read the summaries on Thursday. That'll let you know what we're going to get into. Always something fun here on the InfoSec Wizard channel on YouTube or Twitch. Definitely let me know in the comments if this was helpful, what you would like to learn next time. Jared, same with you. If there's something particular you want me to dive into in malware dev, definitely happy to do that as well. But until next time, everyone, thanks for showing up. Make sure to like and share the channel. Stay up to date with the latest stuff we're putting out. And yeah, have fun.